Hello. Today we'll discuss about the surface integral about the GRDA method. So just we can discuss about the GRDA method. What is the GRDA method and how to solve this problem by using the GRDA method? The GRDA method is basically to calculate the surface integral, and this is on process g of x comma y comma f. Z is the function of xy, dx dy. And that is just we have written here, and this integral, this is a surface integral. And the limiting value of this function g x comma y comma f, then this f value, that is del f by del x square plus del f by del y square plus 1 root over dx dy. This is actually our GRDA method. Here we essentially calculate, because this function is basically defined here. Z is the function of f of xy, and just we can define here del f by del x square means the partial derivative of this function plus del f by del y square plus 1 and just to the power half. And just to define, that is n also, or anything you can define this function. Just one example. One example you have to do, continue this function. G is equal to y to the minus xy. Y e to the power minus of xy. This is your given, and this is the function, and you have to evaluate this integration by using the GRDA method. And here surface is given. Z is equal to 3x plus 4y. And x is greater than equal to 1 and y also greater than equal to 1. This is your part. So Z means that is f is given. Z means that is f is given. Here f, that is equal to 3x plus 4y. We need to record the f of x, or that is del f by del x. And this is 3. Del f by del y, fy, that means del f by del y, and that is 4. Just we evaluate the capital N by using this formula. Capital N, 1 plus fx square plus fy square and this root over below. That is equal to 1 plus 9 plus 16. That is root 26. So this is the n value. And also you have to evaluate the limiting value of the integration, because this surface integration is given. X is greater than equal to 1. That means the limiting value of x, that is 1 to infinity. Y is greater than equal to 1. The limiting value of y, that is also 1 to infinity. So we have to apply the GRDA method. Now double integration, that is 1 to infinity, that is also 1 to infinity. What is the function? Function is given here, y e to the power minus of xy, and n dx dy. N has already evaluated, and just you can substitute the value of n, that is also 1 to infinity, and that is also 1 to infinity. Y e to the power minus of xy, n is equal to 26 dx dy. That is the surface integral. Now this is partial integration. You have to integrate with respect to x. That is value 1 to infinity y e to the power minus of xy divided by y. That is our limiting value 1 to infinity. And root 26 outside here and dy. Y term is cancelled. Root 26 integration 1 to infinity e to the power minus of xy and limiting value 1 to infinity into dy. So just we can put here limiting value of x root 26 here and infinitive e to the minus infinitive. That is e to the minus infinitive minus e to the minus 1 e to the minus y d of y. E to the minus infinity, that is 0, and this value becomes minus root 26 and integration of 1 to infinity e to the power minus of y d of y. What is its value actually? Minus root 26, then e to the minus y, that is of minus 1, integration 1 to infinity. Then what is its final value? A final value becomes this positive 2 root 26 e to the minus infinitive, that is 0 minus e to the minus 1. E to the minus into 0, that is the plus value plus minus, then that value is equal to minus root 26 by of e. So this is our surface integral. That is the surface integral of our present problem. Thank you. Have you seen this problem? Just we have reversed order. I have to discuss again this problem. Because you have discussed about the surface integral about the GRDA method. So first of all, we have the function defined here g of xy in the function of z. Z is defined as the function of f, and evaluated process is gr of this function into 1 plus del f by del x whole square, 1 plus del f by del y whole square. You have evaluated this process, and just you have naming this function n 1 plus del f by del x whole square plus 1 plus del f by del y whole square plus 1 to the power half, that is equal to n. We have to consider. And just one example you take here, the g is equal to y to the power x minus of xy, and x is a surface which given here 3x minus 4y, and x is greater than equal to 1 and the y also greater than equal to 1. X is greater than equal to 1 and y also greater than equal to 1. X is greater than equal to 1 and y also greater than equal to 1, just you have seen here. And the function fx, so we need to calculate the capital N. So first of all, we calculate the fx value, that is 3, fy value, that is 4. And capital N is equal to, we have evaluated 1 plus fx whole square plus 1 plus fy whole square. Then root over is this function. And that is root 26. And the limiting value of this function has already given x is greater than equal to 1. That means it represents the value of x is limiting minus 1 to infinity. Also same y, that is also limiting value 1 to infinity. And whenever we taken the integration of this function, this one, the value of n we have to substitute here. Then n is this put value, and this integration value you have to find out. This is the result of this function. Thank you. We'll discuss the next video.